So another example, you can see that once you know how the operators work, how the variables work, you can just combine them in any way and shape that you want. Rules of precedence. Every operator has the precedence. For example, over here, if I just go back to the way it was written originally, so we had this int conversion plus 0.5 right here. We had all of this, and this was an int. Excuse me. This was an int, and so therefore I go back to just time as an integer data type like this to its original form, the way it was written. Division and multiplication has higher precedence than addition. So therefore, it's division and multiplication happens always before the addition. If you want to alter the order of expression evaluation, right, and of course operator precedence directs compiler how, in what order the operations inside the expressions should be performed. If you want to alter the order, you can just simply parenthesize. Then, of course, something parenthesize, parentheses, by the way, are also called grouping operator. So it groups something as a single atomic unit. So this sub-expression 60 plus 0.5 is now computed before this multiplication, right? Because we said we want to treat it as a single unit, and to control it, you just parenthesize. Of course, it doesn't make sense for the business that we're making here. I'm just using it as an example, right? Other things to keep in mind, that when you look at an expression like this, sometimes it's maybe too complicated. So what too complicated means that it's easy to make a mistake with operator precedence, correctness of each operator. It's just like, looks messy in general. Also, what makes it look so messy as well is that when we're using single character variable names, they're just really terrible when doing actual business, right? It's like here, we could have done something like this: distance, velocity, like this, right? So we could have named our variables d and v. Well, you can argue with me that d and v still works in our example because we have a very distinct, like 3 distinct variables: distance, velocity, and time. We could have named them d, v, and t, something like this. Okay, it does look okay in this example, but if you have more and more and more and more parameters, with some of the parameters that are passed as input parameters to the function, all sorts of things here, it just becomes less readable, increasingly less readable. So my argument is that perhaps using something like distance and velocity in our case, I like this much better. My vote would go to this choice, to use distance and velocity or distance and speed instead of d and v. Okay, it's just a note on style over here, naming the variables, but also, when you have these complicated expressions, simply break them down to multiple steps. The efficiency of the code should not be impacted at all. A compiler will produce, like, if you do this part in one statement like this, and then continue to do the other part in another statement, and then you can even break to more statements and multiple steps. Generally, efficiency of your code will not be compromised. It will still be very efficient, and it will work just fine, right? The same way. So readability, maintainability should be given a very good, highest priority when we write the code. It's important. So expressions are made out of operators and operands, which are variables and literal values. And other sub-expressions, if we use grouping. To give you another example, we can say, we can add another functions over here and say double compute travel, oh sorry, double, I meant to use as a return type, double compute travel time, which is an example of a function because I specify parentheses over here, and I say double distance, right? So this is a function, distance, double velocity, right? And I can make this a function. And what I can do is I can say what I'm computing here is distance times velocity, right? So this is the formula that I'm computing here. So I simply say return value such as this. Okay, so I could compute travel time inside a separate function. I don't know what is the reason, but to demonstrate it here, compute travel time. In fact, let me drop compute, just travel time, right? So this is a function, travel time. So instead of using distance divided by velocity, now I could have said travel time, distance, comma, velocity, and plug in function call. This is an example of a function call. And plug this function call into my formula, and simply what's going to happen here is that as soon as the compiler will see this, it will know, oh, this is a function which is expecting two parameters, distance and velocity. I'm sorry, I should not have used comma here, right? Just a space. So once again, this is a function which is expecting two parameters. It's using this formula to divide distance by velocity, and the result of this immediately is returned back to the caller, right? So it's and then I can plug it in like this inside my expression, just to give you an idea that function calls returning specific values can be made part of expression. All right, so variables, literal values, everything can be part of the expression, and of course we use parentheses for grouping.